It's a full count. Welcome to Vibes Lab. You might not pass the class this semester, but we're always going to pass the vibe check. First thing we're going to learn today is what we're going to do in the Common Lab. Common Lab is where all the different groups will be working on the same thing, so we all learn something together. So first thing you're going to learn is how a mass-spring-damper system works. First thing that's important, you guys know this equation? It's a pretty good equation. Probably learned that in high school, probably learned that in college, hopefully. You got your mass, you got your spring, and you got your damper. Mass is what you're interested in. It's going to move up and down, very cool. Spring is going to repel the displacement that the mass experiences, and the damper is going to repel the velocity that the mass experiences. And so we got this really nifty equation here. That's Newton's second law. And from that we can see that the applied force breaks down into the spring constant times the displacement, and then also the damper times the velocity, and that also is equal to your mass times acceleration, the acceleration that this guy is experiencing relative to this plane here. And that creates the very basic free vibration equation that you're going to be looking at in your first lab here. I'll circle that again so just in case you didn't get it. Now that we understand the spring, mass, and damper components that go to a very basic mass spring damper system, we're going to take a look at them experimentally on the Sanderson machine right over here. You can see we also have a very first student who's ready to... Man, you can't have food in the lab. Hey, Manny, it's good to see you. Put it there, man. It's been so long. I remember you last semester. You were such a good student. I know you're back for some more Vibes Labs, so here we go. We're going to start with the Sanderson machine. Do you remember this from last year? Here we go. We're going to get into it. I know it's your favorite. So first, you're going to take this mass right here, and you're going to put it. Here's your mass, and you're going to put that right in here, Manny. You're going to put it up in Manny. Yeah, a little bit closer, a little bit more. There you go. Manny put the mass in the perfect spot here. This is you got to put it clamped between these two guys, so it's nice and stable. So right now we have a mass spring system successfully put together. And the last element you're going to want to put on here is the damper. Manny, you want to come back over here? We got one more thing for you to do. You got to be careful. We got two things here. You got to screw in the top of this damper into here. For dampers, you got Aunt Jemima's. I like to use Aunt Jemima's. Get a nice viscous, kind of tasty and scrumptious. You know what I'm talking about. And we're gonna put that right in here, Manny, and then we're gonna screw the bottom into the bottom here. So if you want to go ahead and take that over, I'll leave you to it. I know you're an expert. Okay, you gotta put the damper on first, Manny. You gotta, Manny. No, that's a mass, Manny. Can you? Manny, it's really important that you measure all of your different system parameters because we're going to use them in our simulation later to compare against our theoretical and our experimental findings. So first thing we have to do is make sure you measure your mass on one of the scales, and the next thing is we have to find our spring constant. Well, to do that, come over here. Come a little closer. There you go. Spring constant is essentially the slope of a line that follows Hooke's law, which is F equals kx. So if you find different stretches of springs under different weights and forces that are pulling it down, and you take the slope of that, you'll get your spring constant. So coming back to here, how that actually works is you throw a couple more of these guys on here, and you can even mark with the pencil where this little rod is, used as a reference, add some weight, it'll fall down, to make another little mark with your pencil, and you can actually measure the distance more easily that way. So that'll give us our spring constant, our mass, and then to get the damping value, we're going to have to actually look into LabVIEW. Now once you have your damper on, quick note, make sure you screw it in all the way on the bottom so it doesn't start to move around. Aunt Jemima's is getting more expensive with the sugar prices, so make sure you don't spill that. Second, the next part we're going to do is we're going to actually use an accelerometer, and we're going to use this bad boy. Now make sure you read the labels on here because very important, we're going to have to take a look at that when we put it on the LabVIEW sensors. But once we get this going, Manny, where do you think the accelerometer is going to be placed on this mass spring damper system? Which part of it are we? Exactly, Manny. We're going to put it right on the mass. The mass is where it's going because that's really what we're interested in. That's our output of the system, right on there. So make sure you stick the accelerometer onto that system. We're gonna plug it into our signal conditioning box right over here, and make sure you stick it in the pinhole here. And make sure you tighten it all the way, otherwise you're going to get noisy data, which is never fun. Once you get this in here, all the way, stick that on the mass. It should stay still, stay right and still. If you don't have enough putty on the bottom like I don't, Make sure you get some more wax on there so it stays nice and still on the spring damper system. Also, if you want to change your damping value, you want to release this here. This raises a part in the piston that will allow more of the Aunt Jemimas to flow through the viscous oil and allow it to kind of be less damped. If you increase it more, it's going to increase the damping value, and that's going to make there be more restriction when you're trying to move it. So we're going to now take a look at how we get that damping value. So plug it into your signal conditioning box right here. Make sure it's turned on. Turn on your power supply here. That's going to power your signal conditioning box. You should see a green light come on here. If you don't, you're doing something wrong. And then you want to come back over here, Manny, and you can flip the switch for me right here. This is going to be your data acquisition box. All right, Manny. Sorry, Manny. Great, Manny. Good job. You got it. You got the switch right there. No, yeah. And then that's going to complete this part. We're going to take a look at how we actually get the accelerometer data through the lab view and make that work, and also how to do the simulation next to compare our theoretical data from our mass spring damper system. Good work, Manny.